Today we are starting a new unit. The unit is called Solving Systems, and this video is the introduction to that unit. So we're going to start with a basic problem laid out here. Anyone who's been in my class knows that whenever I'm going to teach something new, I like to start with something that we already know, and we'll build from there. So I have set up a picture of an equation. We have a box plus another box plus a dot. This is just one dot equals 9 dots. And we're told that each square has the same number of dots. And the question is, how many dots are in a square? So I'll give you a moment. You can think about it. You can pause the video, talk to your friend, or you can just sort of now watch this unfold. Many of you have probably already figured it out. If these are the same, we can call both of those x, and we can model this with an equation, 2x plus 1 equals 9. That equation we have spent lots of time solving. 2x equals 8, x equals 4. This is the answer to this question. We have found that each of the squares must have 4 dots. We can check that. We had 4 dots here and 4 dots there. 4 plus 4 plus 1 is in fact 9. So that's something we already know how to do. It's an example of having one equation and one unknown. And when that's the situation, when we have one equation with one variable, one unknown, then we get one solution, one answer. We spent lots of time earlier in the year solving equations with one variable. Now in this new unit, we are going to be changing. Instead of having just one variable, we're going to have 2. So we're going to transition to this problem. This is what's new. Now we have one equation, but instead of having 2 squares that are the same, we have a square and a triangle. And they might have different numbers of dots in them. So now if we talk about this, there are some different answers. It could still be that there's 4 in a square and 4 in a triangle, but it could be 3 and 5, or it could be 2 and 6, or it could be 1 and 7. If you allowed negative numbers or fractions, it could be lots of other things. So this right here, with one equation and 2 unknowns, there are many solutions. So in this unit, when we are solving systems, we're going to have more than one equation. We are going to have a second equation. So imagine I gave you this information. Three squares plus a triangle equals 12 dots. We know our possible answers were 1 and 7, 2 and 6, 3 and 5, 4 and 4. Those were the answers that would make this true. For these two things to be together, we're going to put them in a system. We'll use this symbol to say these two equations are tied together. Their solution must work in both of them. And this unit is going to be learning a bunch of ways to solve problems like this. Instead of shapes, what we're going to have are equations. This first equation could be modeled x plus y. If we subtract this one over there, equals 8. We could model this one as 3x plus y equals 12. This has an answer. There is exactly one x value and one y value that will solve this system. The answer to that is called the solution. We can write that answer in 2 different ways. We can either just make it very clear, x equals this number, y equals this number, or we can write it as an ordered pair where the x value comes first and the y value comes second. So again, I'll give you 5 seconds. You can pause the video if you want to think about it. Then I'm going to finish this video by giving you the answer. If we try those different values, the only one that will work is this right here. If you plug in a 2 and a 6, 3 times 2 is 6. 6 plus 6 is 12. 2 plus 6 is 8. And so our answer can be written in either of those ways. So that is your introduction to solving systems of equations with two variables. The next couple videos will be showing you some different techniques for solving these types of systems.